I don't even think we post this, do we? Or do we?
I don't think so, but it's probably good just to have it just in case.
Yeah, just in case we want to too. Okay.
Yes.
Okay, so that kind of helped when it said independent, but when I did it on the review, it just differs. When you're looking at the difference, you're not looking for the mean.
Yeah.
Questioned it here, they worded it totally different in the actual. That's how they questioned it.
Like how they do
the
that.
Word differs is not even in it. Yeah. Okay, so number 3. Okay, let's see if this one's closer. A human resources manager reported data from a recent involuntary reduction in force at her company. You are an attorney and want to determine if age discrimination was a factor. It's illegal to discriminate against employees because of age. The company reported the number of employees in 2 groups. So that's one of the things I would underline right there, 2 groups, because you know you got 2. 40 years old or younger and over 40 years old. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally. Appropriate. So you're not looking for the mean in that either. You want to know, like 85% of these were treated, you know, appropriately and whatever percentage. So you're looking for
Proportions.
You're not looking, yeah, you're not looking for, my son was just going through this with me earlier today. And that's one of the things he said is to ask yourself, if you wrote this down, like on if we were going to chart this or put it into we're going to put it into the table, what would we put? So, you know, you've got 2 groups and I don't know if you guys can see this, but this, yeah, you won't be able to see it. But it said when it's 1 and 2 groups, the hypothesis is always group 1 is equal to group 2. So P1 equals P2. Yes. So what they're asking in this is one greater or is one less than? So you know that that's a proportional thing. I don't know. Does that make sense?
Proportions.
Yeah, that's what I think. Is that the one you got?
It is. We're doing good. Yep. It is tested.
Okay. Okay, awesome. Is this making sense? I think it's really confusing, but I think it does help if you go through them. What I started doing is going through and any pertinent information I would underline, because even narrowing it down to knowing that you're doing 2, you know, cuts a lot out, and then you can kind of just go from there.
Yes, I think this is going through it and like talking through it, because like as blonde as I actually truly am, I would not have noticed that it says test of independence on the chi-squared. I'm like, oh, chi-squared test. Like, but the only word in this is independent of independence. Good catch.
You know what it was? It didn't have the word independence on the review question. So
yeah. Okay,
so number 4. A survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion right there, I would underline proportion, because we know right then it's going to be a proportion test. Of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. Which hypothesis test would be the most appropriate for this analysis? So are we doing 1 or are we doing 2? Because we know it's a proportion test. Okay, and this is, and I would write me the test of 1 proportion. What you're testing for, you measure the difference between a sample proportion and a population proportion, or a population sample, sorry.
Right.
Measure the difference between a sample proportion and a population sample. And that's what they're asking for here.
So it was a sample proportion and a what?
Population sample. So what they're saying is they took these random people, 248 of them were heavy players. And of those, 152 were male. So they're saying, what proportion of these male people is different than the proportion of males in the population? So you know that they are going to be comparing the proportion of the heavy male players to the population heavy male players. So that means it's the test of one proportion.
Yep. It is.
One.
Got it. That's super good.
Test of one.
Things explained. Yeah, that was it. Just having these things explained to me is like, oh, got it.
Well, my son is actually in medical school right now. We're at the college right now, both studying, and he went over these with me this morning because he's done statistics. And he gave me like those little key words, and that's like so helpful to me. I just need like those little points. Okay.
Question 5. A student project compared the effectiveness of 2 different combination locks.
Okay, right there, I would underline 2 different combination locks. I mean, if you have this on paper, I would think, okay, so you know right there, you're dealing with 2 things. Okay, go ahead.
One of the locks turned clockwise first, and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The time it took them to open each lock was recorded. They wanted to determine if one of the locks was easier to open. Which hypothesis test would be appropriate for this analysis? Hey, calm down. Sorry, my dogs are crazy. Okay, so
what helps me with this one is you know that it's 2, but you know that it's 2 specific. So for me, it's like, this is like a brother and sister thing or a husband and wife thing. You know that because they're testing 2 locks. So because they're doing 1 lock,
they have to do
you know that the second lock is determined. So it's got to be a paired.
A paired?
Mm-hmm. It would be a paired, I think, a paired samples test because they're testing 1 lock and then they're testing the other. And they're using the same students to test one and then the same 2 students testing. How much mean time is it going to take to open these? Does that make sense?
Yeah, because they have the counterclockwise, they have to have the clockwise.
Right, right. And they're using the same students. So, you know, these students are going to do this and they're going to see how long it took, what the mean time was, and then these students are going to do, the same students are going to do the next lock and find out what the mean time is for that too. So I think it's a paired samples.
It is most definitely a paired samples test.
Okay. Cammie, is this helping at all in Chase?
Yeah.
Okay.
I'm just using my microphone. I got a lot of background going on right now.
Okay.
All right. Question 6. A bank employs 2 appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence interval would be the most appropriate for this study?
Okay, so think of what it says in the very first sentence. A bank employs 2 appraisers. So you know it's 2, and you also know that they only have 2. So they're going to use the one, and then you know it means they're going to use the other one. That first one's going to determine who the second one is because they're only using 2. So Same thing. I think this is a paired also, because what they're looking for, let's see, what does it say? To make sure in this case the bank evaluates 6 properties, which confidence interval would be most appropriate for the study? So you're not looking for 2 proportions. You're looking for just the confidence interval between the 2.
Mm-hmm. That is correct.
So I believe it's a paired.
Yep.
Is that right?
Mm-hmm.
It's really helpful that you know these answers.
It is. It's nice. Just because even if like I couldn't, if like we couldn't find a way to get to the answers, at least we could like try to work backwards. Like
yeah, exactly.
That I've liked from it is it's helpful.
Chase, is this helping at all, Chase?
Yes, it is.
Okay, awesome. Okay, so let's go. In a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting they were satisfied with their career path was reported. The same data was also reported for accounting majors. You decide to construct a 95% confidence interval to see if the observed difference is, you're looking for a confidence interval is appropriate for the study. So we're looking for 2 things that really aren't related. What is it? Psychology majors and accounting majors. So 2 things that are not related. And they want to find the difference. So you're looking for proportion, like this percentage of this, that percentage of that.
Yep. So it would be confidence interval for 2 proportions then.
Mm-hmm. Yeah, that's what I think it is.
Yep. Yes, that's what it is. Oh, not looking at the next one. Okay. Confidence interval for 2 proportions. Okay.
Awesome.
Double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that is a true assertion by the company who makes them. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount in the regular Oreos. Which confidence interval would be most appropriate for this study?
Okay, so this one I thought was kind of tricky because I was thinking that they were comparing the double stuffed Oreo and the Oreo, but they're not. They're only doing the one.
So,
and then, go ahead.
What's the difference between the Z confidence and the T confidence?
What does it show in that little thing? Let me look at my little chart he did.
Because I don't know if they have the same, like that one just talks about like which test to do.
The chart says that for the one group, the sigma known is 1 sample mean Z test, and the sigma unknown is the 1 sample mean T test.
Oh.
Okay, so, yes. So we
got it.
Yeah, mitigation. Then we'd do the 1 sample Z, and if we don't know, then we would do the T. Is that what you're saying, Chase?
I believe so. If we do not know, we do the T test.
Okay.
Since it doesn't say what the mean is.
Yeah, sigma unknown. So we don't know what sigma is, so we would do T confidence interval.
Yep.
Okay, this is slowly starting to make more sense, guys. Thank you, Chase. That was super, super helpful. Appreciate it. And that was the right answer. 1 sample T confidence interval. Go team.
Okay.
I'm just grateful the professor decided to send us that chart.
Yeah, don't you think that could have happened sooner? I just said that to my son. Why didn't he send it last week when we were learning all this? And I just happened to notice it today. I checked my email for something else and saw it. I don't even check my email very much.
Yeah. Okay. Which of the following best defines the notion of the significance level of a hypothesis test?
Okay, this one I think, and I just know this from taking it, this was on one of the other quizzes or tests, the probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true.
Yeah, that was on the last homework quiz.
Yeah, that's what I thought.
I totally guessed on this one and got it right, but I have no idea why.
I think I
Probably.
I think I said the probability of a type 1. I'm hopeless.
No, because that's close. That's what the p-value is. So I'm pretty sure they're asking the same. The significance of a p-value is the probability of a type 1, I think. So what's the answer to that one, Cassie? Is it the probability of observing a sample?
The probability of the type 1 error. Now
That's the answer?
That's number 9, right? Well, yeah.
No, because it actually would be number 8, because we're on a...
Oh, yeah. I'm just doing the actual test.
Yeah, I'm in the quiz too.
So number 9 would be, which of the following best describes the notion of the level of the level of a hypothesis test? And what was the answer to that one, Cassie?
The probability of the type 1 error.
Huh.
Didn't we just have that, Chase, in that quiz, and that was the answer?
Yeah, it was the long one, and it got it right.
Probability.
Yeah, me
The
too.
wording was different, though. Can you go look at your test?
Yeah, give me a
That's a lot
second.
to ask. If you don't want to, you don't have to.
It'll only take a couple seconds.
Probability of the...
Whoa.
The significance level of a hypothesis test.
I think it was...
Oh, you know what? You're right, because now that I'm reading it, that is what a p-value is. The next one is that.
Which of the following defines the notion of the p-value of a hypothesis? Okay.
That's the probability of observing. Yeah, I think you're right. I think it is the probability of a type 1 error is number 9. It must have been a p-value question, Chase, because I remember it too.
Hopefully you can let me in. Let's see.
Value of a hypothesis test. I'll check on my thing to see what the right answer is. Yep, the probability of observing a sample. Yeah. So we just...
That one's for p-value?
Probability... Wow, that was special. Of observing a sample statistic.
So number 9 is the probability of a type 1 error.
Mm-hmm.
And then number 10,
More extreme.
the p-value then is the probability of observing a sample statistic more extreme. Yeah, that makes sense when you think about it, because you're always comparing your p-value to see if you're going to reject the null or not.
Yeah, that's
so it does make sense. So what the p-value is just a sample statistic. It helps you decide which way you're going to go.
more than the one actually obtained.
Yeah.
Yep.
Yeah. So that does make sense.
Because that's the level of significance, right?
Right.
This is the question we were thinking of in that quiz.
Oh, it is?
It's the p-value?
So is this one. Yeah. So the more extreme one, yeah. I don't know why the other one looked familiar.
Yeah, it did to me too. Okay.
We're in previous quizzes.
It's all kind of running together now.
Okay. You ready for 11?
Yep.
Okay. Suppose you create a 95% confidence interval for a mean and get 10, 20. you've been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. What exactly does this mean?
What does this mean? I've missed it every time.
95% of all 95% confidence intervals actually contain the true mean.
Yeah, this is one that I contacted the tutor on because I kept missing it too, Chase. And she explained it. So yes, that is the right answer.
But why is it?
Yep.
We only hope they will ask it on the exam. Now that we know.
Probably not.
I always want to say there's a 95% chance.
Mm-hmm.
Yeah.
So it's always 95% of all 95 or 75% of all 75%.
Right.
That sounds so dumb.
So, yeah.
Okay. Okay. Take a simple random sample of 100 adults in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people who in town invest is P equals 0.3 or 30%. What is the mean of the distribution of the sample proportions?
I think it's 0.30 because it says P equals 0.30 and the mean of the distribution sample proportion is P.
Yeah.
Is the answer 0.30?
It is definitely 0.3.
Okay.
What is the standard deviation of the distribution of the sample proportion?
Okay, so now we've got to do the formula.
Okay,
so you've got to do P times, I don't know, let me see if you can see it.
I can definitely.
Can you guys see that?
P times 1 minus P.
Yep.
Over N.
And then square it all. Yep.
Is to get the mean.
So we've got, so we do, so it's 0.30 times 1 minus 0.30 over 100 because the sample size was 100.
Yeah.
And then do the math and then
okay. We'll do that now. Let's see. Wait.
0.046.
Yeah, that's what I got was 0.046.
Okay. So we do 0.3 times 1 minus, so 1 minus 0.3 equals times 0.3 equals divided by 100 equals 0.0. Okay, actually, square root of 0.002. And you guys said you got 0.046?
Yeah. Yep, that's what I got.
Let's see if that's right. 0.046. I'm going to put that in. That is correct, guys. Go.
Awesome.
Tap it. Okay. What is the probability that your random sample of 100 adults will have a sample proportion less than 0.25? Okay, so this one was tricky for me because you got to find the z-score and put it in the probability outlet. Anytime it's going to say probability, you know, you're going to have to get the z-score and put it in. Okay. So I put 0.003, but they're saying, I mean, if we figured p hat
then we would have to put p hat in there, but they're not asking for.
You're disgusting.
There's 0.25. What would it be? So let me find the.
So do we have, so we have to find the z-score
So,
first.
right, so you want to do point, I don't know, can you guys see this? Let me see.
Right there.
Well, I can't see, let me see.
Like, I don't know which one it is.
Yeah, I'm trying to see which one is showing. Yeah.
Oh, it's right there.
Z-score equals p hat minus p over, and then it's going to be the standard deviation. So p times 1 minus p, what you just did.
So p hat minus p over the standard deviation.
Which their formula for that is what we just did before, the p times 1 minus p over n squared. I can't see if you can see the.
Yes, I can see.
See it right there?
Yep. Okay. Perfect.
So we got to figure that out. So we want to do 0.25 minus 0.3 over, and we already have the standard deviation from the last question, which is 0.046.
So we want to do
0.25, because they're saying if the sample proportion was 0.25, they're kind of giving that to us.
So that's
so
p.
Yep. Yep. Minus p, which we already know p from number 11.
So 0.25 minus
0.3. Over 0.046.
0.046. Okay.
And then that'll give you your z-score, and then you got to plug it into the
0.25 times 0.3 divided by 0.4. 1.63.
I got negative 1.087 for the z-score.
That's what I got, Barry. I got the same thing as you.
You did? Okay.
Wait, what did you get?
Try it again, Cammie. It's 0.25 minus 0.3.
Oh, minus. Okay. Got you.
Yep.
I don't know why I thought that was like a times for some reason. My handwriting's that bad.
Oh, there you go.
0.25 minus 0.3. Yeah, that gives you a negative. Oh, for sure. Divided by 0.046. Negative 1.087.
It's asking us for what is less, going to be less than 0.25. So we're only going to shade to the left.
So we put 1.087, and then we shade to the left. So
yep.
14% or 0.139.
Yep. On the test, it only has 0.138. I mean, on the review. So I don't know whether to put 139 or 138.
Let me look at this. 0.1385. Let me look.
Oh, so it'd be one, if it's 385, then it'd be 9.
But in the test, it does say 0.138. Like
oh, yeah. Okay, then I'm doing 8. Yeah, doesn't make sense.
That doesn't make sense at all.
Because I did get 0.139, but that wasn't an option. So
I remember that was one that was always wrong. In fact, the professors who told, like in the last class I took, they were just like, "Oh, you need to change that. It hasn't been changed yet."
Oh.
Like they even gave us a review quiz of a different professor who said the exact same thing. They just never changed it. So that's an error on the test. That's not, like, if you put 1.39 in there, you'd be right, even if you didn't get the point for it.
Okay. Well, I'd rather be right and put 139 or 138 if that's what's going to be right. I'll just put it in my notes that it's actually 139.
Guys, we're doing so good. Okay. Use the following information for the next 7 questions. We have this information. Blue scores. I don't know. Let's see. Okay. Use the following.
And just always remember that if they give you P1 and P2, you know it's going to be a 2 proportion test.
P1 and P2. Yes, because the P equals proportion.
Yeah.
So this is why I get confused. So M1 minus or M1 equals M2. That's the mean.
Mm-hmm.
P1 equals P2 is proportions.
It's 2 separate proportions, yeah, that they're trying to find out.
Genius. Okay, goodness.
Yeah.
Okay. A cupril is meant to control hypertension. In clinical trials of the cupril, 2,142 subjects were divided into 2 groups. The 1,563 subjects in the experimental group received a cupril. The 579 subjects in the control group received a placebo. Of the 1,563 in the experimental group, 61 experienced dizziness as well as a side effect. Of the 579 subjects in the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of people who experience dizziness while taking a cupril. Let P2 be the true proportion of the people who experienced dizziness but did not take a cupril. Create a 95% confidence interval for P1 minus P2. Input the margin of error, lower and upper bounds below, rounding to 3 decimal places. So, let's see.
So where it says let P1 be the true proportion of people who experience dizziness, I just go back up in there and I say, okay, who are the true proportion that experience dizziness? And so that's going to be 61 people.
Is that X1?
Is that like the mean one? Yeah. Yep. So when we go to the 2 proportion test, 61 is going to be X1.
Then N1 would be 1,563.
Wait, hold on. Sorry, guys. I was a little bit slow in being able to get this test up. Okay, so the true P1. Oh my goodness. Sorry. Let me go back to this.
Stop touching me.
Okay, so the true P1.
Go ahead, Chase. You got it.
Yeah.
So what? So hold on. So X1 is 61, and N1 is 1,563. And then X2 is 15, and N2 is 579.
So X1 is 61.
Yeah.
Yep.
N1 is 1563.
Yeah.
X2 is 15.
15, yeah.
And then N2 is the 579.
Yes.
Mhm.
Okay. The confidence level is 95. And the type of test is minus, right?
It only has greater than, less than, or not equal to.
So what do we put?
What is it saying in there? It'd be 2%.
It doesn't say. I don't think it matters
Yeah,
because it's not asking for the p-value. Because that's the only thing that changes when you do change the type of test.
Yeah, and they're going to have you change it as soon as we go to the next question. It says perform a hypothesis test to see if the proportion of experimental group subjects who experience dizziness is different than the proportion of control group subjects. So you want to put
Not equal.
not equal to, yeah.
Okay.
Not
So
equal to.
for 15, what is the margin of error for this 95% confidence interval?
I got 0.016.
The margin of error. Where am I looking for this?
What'd you get, Chase?
0.016.
I got 0.003.
Where are you finding this?
Well,
confidence
I
interval.
have mine set up all the time so that when the confidence interval is plugged in, then it does the confidence interval. Because it's the upper bound minus the lower bound divided by 2, right?
No, that's only if we're doing, oh, oh yeah, they're asking for margin of error. Okay, wait a minute, I skipped this one.
Wait, margin of error.
Yeah, the negative 0.003 is the lower bound.
Error.
Okay, just a sec, I didn't figure this out because this wasn't on the quiz, just a sec.
Wait, so the margin of error equals upper bound minus lower bound divided by 2.
Yeah, and you want the upper and
Yeah.
lower bound in your parentheses.
This lower divided
So it
by
doesn't divide the lower bound first before it subtracts.
Okay, so it would be 0.029 minus negative 0.003, which equals 0.032, right?
Yeah,
Divided by 2 equals 0.016.
yeah, that's what I got.
Yep, that's what I got.
0. That is not a point. That's a 0, 1. I'm always afraid that I'm going to put like a comma or some stupid thing to make my answer wrong.
Well, I have it saved in the Excel sheet, that formula right next to the confidence intervals.
That's a
So if I ever plug it in, it'll always calculate the margin of error for me.
Oh, that's awesome.
Okay.
So I don't have to keep doing it.
0.01. Good job, Chase. You the man.
This is one of the only things I know how to do in
Okay.
this class.
Negative 0.003. And put the upper 0.029.
Okay, are those right, Cassie? Is that right?
Can you double check? Sorry, I got ahead of myself.
No, go ahead.
Negative 0.003 and 0.029. Yes, we're doing it right.
Okay, awesome.
Perform a hypothesis test to see the proportion of experimental group subjects who experience dizziness is different than a proportion of control group subjects who do. Use a level of significance of A equals 0.05. What are the appropriate null and alternative hypotheses?
We said this is the not equal to one.
Mm-hmm.
So HO equals P1 equals P2?
Yeah, always remember that in a two proportion test is always P1 equals P2, always.
And then the alternative, which would be HA, is P1 does not equal to P2.
Not equal to, yep. But that's not always the case. The null can be either not equal to, greater than, or less than. But the null hypothesis, or the alternative, the null hypothesis, the alternative can be not equal to, less than, or more than.
That is the right answer.
This is the first one?
Yep, the first one. P1 equals P2, and then P1 does not equal P2.
Okay.
The value of the test statistic is?
I believe it's 0.145.
Or 1.45?
Right. Oh, no, sorry. That's the p-value, sorry. The test statistic is 1.458.
Yeah, that's what I got.
1.458.
And then the p-value is 0.145.
Okay. Let me check. The test is indeed 1.458. Okay, and the p-value 0.145 is also correct. Okay. Okay. Is there sufficient evidence to conclude that the true proportion of people who experience dizziness while taking Acupril is different than the true proportion of people who experience dizziness while not taking Acupril? So you're looking at the p-value.
Yep.
So
And
if
the
the
p-value,
p-value is low, HO must go. So that means, is there sufficient evidence?
No,
No,
because we
because
failed to accept.
0.05 and the p-value is 0.145, so it's larger.
There's
So
insufficient
if the
evidence to say that the HO is correct, right? So no, I failed to accept the H. Oh.
It's no, I failed to reject the null.
So
The
HO.
null?
So reject the HO, yep.
Okay, so when it goes to fail to reject and reject, it's always the null, right? It's never the alternative?
I
Yep,
think so, yeah.
always, it's always the null. And you
Okay,
never
see,
say,
that makes sense.
you never say I reject the null. It's always, I failed to reject the null.
You never say I
Yeah.
accept.
Or you never say I accept the null.
Yeah.
Okay.
So it's no, I failed to reject.
All right. Go team, we're doing good. Those are the correct answers. No, I failed to reject HO. Okay. A survey was conducted of 1,279 randomly selected adults aged 18 and older. They were asked, are you a morning person or a night person? The hypothesis for the study are HO being a morning person or evening person is independent of age. And
So we know just by that information, we know that that's a chi. We know that's a chi-squared test. Because that's the only one that has a hypothesis and an alternative written that way. It's either independent or not dependent. So we know right away that's a chi-squared test.
Okay.
Sorry, interrupt you.
It's okay. It's good. It's good. I was just pulling up the test. And HA being a morning person or an evening person is not independent of age. The results of the survey are given here. So we have to enter that into the chi-squared test.
Yep.
Chi-squared. So we just enter those two rows, right?
Yep.
Okay. Okay. Conduct a test of independence using the level of significance of A equals 0.05. Calculate the test statistic for this hypothesis test. Assuming the requirements are met or for this test are satisfied.
Okay, good.
So the test statistic for this test is 6.579.
Yeah.
Oh, I got 6.5. Yeah. On the test, it says 6.580. Is it 79?
That's what it came out to be. 6.579.
Are we supposed to round it to Let me look.
I wouldn't think so.
No, because
What's
I pushed the decimal out and it came out to be 6.5789. So rounding up would be 6.579.
Yeah. And the test says that 6.579, my answer is that is correct.
Okay.
Calculate the p-value for this hypothesis. Point.
Yeah, 0.087.
Yep, that's what I got for, yep, that is correct. Okay, should you reject the HO or not? So the HO is.
What did you wait? What did you guys get for the p-value for that?
0.087.
Did you check and make sure that was right? Is that right?
That is correct.
0.0. I got 0.866 somehow. Okay, I'm gonna have to check that one. I don't know what I did.
I wonder,
Okay.
when I type in my numbers, if I don't leave that box, like I have to make sure that I leave that box or else it doesn't enter it in.
Okay.
Sometimes that happens for me.
Sherry, those are the right numbers. It's just off one decimal place.
Yeah, I don't know how I did that, but okay. So it's 0.087, right?
Yes.
Okay.
Should you reject the HO or not? Explained. So the p-value was low, so the HO must go. So there's I failed to reject.
Mm-hmm.
So should you reject? No. There's the p-value is less than 0.5.
The p-value is greater than 0.5. Because if the p-value was smaller than 0.5, then you would have rejected the null.
Oh, it's great. Okay. I was thinking that it was 0.5. So that was my brain messing up. So
0.05.
value is greater than 0.05.
This seems like one of those trick questions because it's asking, should you reject? When normally you would say no to it, but it's just asking a backwards question.
Value is greater than 0.05.
Yes, that's the first one.
Should you reject? Okay, wait a minute. No. Should you reject the null? No, we shouldn't reject.
Because the p-value is.
Oh. The p-value is greater than 0.05.
That was like the confusing way to get to that.
I knew it was a backwards question.
Yeah, exactly.
Should you reject the HO or not? No. You fail to reject the HO because the p-value is greater than 0.05, correct?
Yep, that's right.
That is the right answer. I already looked at it. That is the right answer. I was just wording it out in my mind. Okay.
So then we have insufficient evidence to say.
Because we failed to reject the HO, so we have insufficient evidence to say that.
Independent of age, right?
That being a person is independent. Is it independent or is not independent?
Okay, we have insufficient evidence to say that being a morning or evening person is independent of age. We have insufficient.
Not independent.
Right, because that's what the not independent. I hate these questions. I always get it backwards.
Well, you just have to go up and look at the HO and the HO again.
Yeah, and what was the question?
So, dang it, no. We have insufficient to say is not independent.
So the null hypothesis is being a morning or evening person is independent of age.
No, it's
not. So we have
because you failed to reject. Right?
That's the alternative hypothesis.
Yeah.
So the hypothesis, being a morning or evening person, is independent of age. And we did not reject. So we have insufficient evidence to say that being a morning person is not independent of age.
That is the last one.
Yeah. Is that right?
We have insufficient evidence to say that being a morning or evening person is not independent. Boom.
Okay.
Yay. A recent book noted that only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers that had graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period. So we're using that two proportions, right?
Except think about it. He says, let P be the true proportion of investments. So we know that it's a proportion, right?
Yeah.
They're talking about 20% of all investments, but they're not comparing anything.
Oh, so
they're just saying, yep. It's just a one proportion. And if you go to that thing, you know, where you have to type in the null.
Yes.
It tells you like the 20% or whatever. So we put 0.2%. Yeah.
Okay. So confidence level is 95. So X would be,
let's see, let P be the true, what does it say?
Yeah,
how did we do that?
Is it 50? 50?
Yes.
Wait.
Yep. Yeah, that's right. 50 is X.
And then
that's the true mean of the population. And then the sample is 200. So N would be 200.
Guys, this is kicking my booty. Ugh.
We're getting it though.
I'm getting it though. That's awesome. I'm getting it. Okay. Based on the results, based on the results of the sample, create a KP input lower and upper bounds. Input the lower bound. The lower bound, oops, mine says num.
Okay, what didn't you must have not put something in.
Is it not equal to?
What does let's go back to see what the question says. Whoops.
Wait, I think, oh, I put in 95 instead of 0.95 in the confidence level.
Okay, that would do it.
What type of, does it matter?
A random sound, what does it say? Okay, so it says 50 of these outperformed.
So would that be greater than?
So greater than, yeah.
Okay, so for lower bound, I got 0.190.
Yeah.
That's what I got too. Is that what you got, Cammie?
0.19.
Yeah, that's what I got.
Okay.
Upper bound was 0.31.
Yeah.
Yeah, you want to make sure those are right, Cammie or Cassie?
Yeah, I will double check those right now.
Okay.
0.19 and 0.31. Doing it.
Awesome.
Okay. Suppose you had been in charge of what? Oh, I think this is a completely different thing.
Yeah, I don't have any idea how to do this. This was one of those ones in the work where you multiplied the group by like 1,000 or something. I mean by 100 or
Okay.
I don't know how to do this. What's the answer, Cammie? And let's work backwards.
So, okay. Suppose you had been in charge of designing a study. What sample size would you need to construct a margin of error of 2% with 95% confidence? Use the prior estimate of P star equals 0.2 for this estimate. Okay, so the answer is 1,537.
God, I don't know how they got that.
Do Chase, Jamie, do either of you happen to know what to do with the one?
I know we did cover it, and it has something to do with multiplying the sample size by like 10 or 100 or 1,000, but it doesn't make sense with this one because I think this was only, it was 200, so that doesn't even make sense.
Okay, so I looked at the that I have. Look for the sample. N equals 4 times the standard deviation.
Wait, could you start over? Sorry, there was a lot of background noise.
So the sample size equals the z-score times the standard deviation.
Times?
Okay, sample size equals the z-score.
Mm-hmm.
Okay.
Times the standard deviation.
Deviation.
Divided by the margin of error.
Margin of error.
And then you square it.
The whole thing?
Square.
The whole thing. So I don't know.
So how would we?
But it would be. Can you see it?
Kind of. The z-score deviation over margin of error squared. Yeah. Rooted. Or rooted. Okay, so is this question still in reference to the first question? Oh, no,
Yeah.
next question. Yeah. Oh my
Yeah,
God.
it is.
Find it. Come here. Right now.
95% confidence error would be 1.960.
Oh, that is it. Okay, I wasn't even. 1.96. And then you would do P. The z-score would be 1.96 because it's a 95% confidence level. Genius,
Where's
Tammy.
that, what are the things for that? 95 is
So
1.96.
1.96.
Yeah.
And what are the other ones?
90 is 1.645.
1.645.
Yeah, and then 99 is 2.570.
2.570. Okay, so the z-score for this one would be 1.96 times
the standard deviation.
Do we know what the standard deviation is?
Let's see, are we looking for the standard deviation of the confidence interval or the standard deviation of the hypothesis test?
Oh boy.
That's the real question.
Over the margin of error though. So the margin of error.
The margin of error is going to be 0.2 because that's what they want us to do for the, that's the margin of error they gave us.
Okay.
So it's 0.02 because it's 2%. Sorry.
Okay.
But where do we put that in, Cammie? I don't get it.
So it goes under, so right now it's 1.6 times the standard deviation over 0.02.
What? I don't get it. I'm totally confused.
So use the prior estimate, P star equals it says what sample size would need to be constructed for a margin of error of 2% with a 95% confidence. So we get the margin of error is 0.02 because it's 2%. And then the 1.96 is the 95% confidence. So we need to find standard deviation.
Yeah. Standard deviation. Let's try and use both of them and then see if the answer's right compared with what you have in there. Because I'm not sure which one I'm supposed to use for this.
Okay, so can you explain both of the ways to get standard deviation? Because now I'm confused.
I'm not sure. I was just looking at the confidence, the categorical, the one sample Z proportion thing, the numbers that they plugged in.
Mm-hmm.
And the descriptive statistics, it says the standard deviation of confidence interval. And then it says the standard deviation of the hypothesis test.
Cute.
That's what I'm looking at. I don't know how they got those. I just plugged it in.
Wait, you plugged what in where?
The one sample Z test for proportion, because we're using the same.
Oh, okay. So we standard deviation.
Yeah, I still don't get.
Oh, okay. So they're there. They're already there.
Yeah. So we just have to figure out which one we're supposed to actually use.
So we're gonna try both here. So 0.0306 and 0.0283. Okay. We'll see what happens. 1.96 times 0.0306 equals, divided by 0.02 equals. Bandit, don't you dare. Okay. Square root, let's see. Square root of 2.9988 equals 1.7317. What does that have to do with anything?
Yeah, I can't figure. I still don't get it.
All right, let me try this second one. The second number. I don't. 1.96 times 0.0283 equals, divided by 0.02 equals. Okay. Bandit, stop. No. The square root of 2.774 equals 1.6. Yeah, this is just giving us. I'm so confused, guys.
Yeah, I am too.
What's the answer, Cassie?
The answer is 1,537.
Okay. Yeah, maybe we just have to solve for the standard deviation in the normal way and use like the scores that we got there.
I know if we go back in the homework, we'll find it. Let me see. I'll look.
So when we use that P times 1 minus P over N to get the standard deviation?
That would probably be it. So
would it be the P value, so 0.039?
minus 1 minus 0.39 over 200.
So we don't know the, is it 200? What did you get for that, Kimmy?
I'm still doing it. So for that, I got 0.0109. 0.009. Yeah.
Wait.
0.
Sorry, you're really up and down.
Okay. Sorry, so I got 0.0109.
Change. All right, hold on. Let's plug this in and see if it works. Get off. Times. Square root. Weird. Okay. Square root of 1, 0, 6, 8, 2, 8 plus. Yeah, this is not coming out. It's just coming out as like 1 point something, which does not get us anywhere close to 1537.
Yeah, I don't know. Maybe this is for a different. Huh.
I can't find it. While we go ahead and finish this, I'm going to text the tutor and see if we can find it.
Okay.
Okay, we'll move on to the next question.
Yeah. That should be the formula. We might just not be finding in the right things. The right numbers.
I just don't know how they can be any different. Like, what else would it be?
Yeah, I'm not sure.
Okay, we'll move on to the next question. So, suppose you wish to see if there is evidence that graduates of one of the top 10 business programs performs better than the other investment managers. Conduct a hypothesis test. Use the level of significance of A equals 0.05. Which of the following pairs of hypotheses is most appropriate for addressing this question? Would it be HO equals P equals 0.2 and HA is P is greater than 0.2?
I think that would be right because we're trying to see if they do greater than 0.2.
That is right, guys. Okay.
I need to pause for like 2 minutes.
Okay.
Okay, so the null is equal, the alternative is greater than, right?
The null is equal, and then the alternative is P is greater than 0.2.
Okay, that's what I got.
1 from the bottom.
I just text her. If she will get back to us right away, if she can, she will.
Yeah.
And if she doesn't, she'll get back to me later and I'll just text it to you guys.
Okay. I'm probably going to take the test like right after this because
you're trying to get ready to go.
Fresh in that too. I'm like, let's get out of here. But then at least it will be fresh in my mind. I feel like even tonight will be like, I'll lose half of it.
Yeah, and it's kind of just a relief to get it done.
I actually feel like I might be prepared for this test a little bit.
Good, awesome. Only one more after this, yay.
Oh my gosh, that's like the most heavenly thing to think of ever.
Yes, it is. It is. What is your major, Cassie?
I'm marriage and studies.
Yeah, me too. I've had my practicum this term too, so I'm very excited to be done.
So
I think we're all marriage and family studies. So I'm pretty sure Cammie is too.
Oh yeah, so we are. Awesome.
was your practicum like super hard?
No, it was awesome. Have you done yours yet?
Uh-uh.
Oh, if you want to contact me, the instructor professor is awesome. They try to make it as easy as you can. I mean, as they can. There's a lot of information, but I taught a workshop on stress reduction through mindfulness.
Mm-hmm.
And so yeah, if you decide you want to do that or need any help, I can send you in the right direction.
Oh my gosh, yes. Okay. What class are you in?
I had Buswell, Buswell, and she was like she was very, very good.
Because like when I was in my stats class last semester, another girl was going through her practicum at the same time.
Mm-hmm.
She was like drowning. She was like, I cannot handle how much work and how hard.
Well, the biggest thing I would say is that a lot of people choose not to have a workshop, a family relations thing, or an online curriculum. Everybody thinks that everything is easier than the workshop. It's better to do the workshop for the same reason, kind of like the project we're doing for this. The other two alternatives, you have to interview. You don't get to pick what you teach on. You interview people and you find out what the need is, and then you decide from there. If you know what your workshop is going to be on and you start doing research early, just stay up on everything.
Yeah.
But the biggest thing is to start doing your research early, checking into what you're going to teach, what you're going to do, all of that. But if you decide to do anything like that, I can send you articles. And my son just gave me this really awesome, I didn't know about this before, because you got to all have peer-reviewed stuff. So I go on EBSCO or ProQuest or whatever. He just gave me a website called google.scholar.com. And you can, it's the what? Said it's part of Google, and he was just looking up articles earlier, and that's what he was looking up for this extra credit thing that we have for this class.
Mm-hmm.
So if you guys are going to do that extra credit, you can put in google.scholar.com, type in something having to do with our major. I think that's what he said it had to be. It has to have a p-value, but there are tons of articles having to do with marriage and family studies.
Yeah.
So that's like super helpful.
Awesome.
So yeah, if you want to, yeah, so use that. But yeah, when it comes time for you to do your practicum, just text me and I will help you in whatever way I can, because it really wasn't too bad. You just have to keep up on it and you know, do it as you go. But there's like 2 weeks that you kind of feel buried as you're just putting it together to teach.
Yeah.
But as long as you keep up on it, it was informative. It was like a really good experience. So
That's so cool.
All right, we got sidetracked.
All right. So the next question is, what requirements must be
met to ensure that p-hat is normally distributed? That would be number 1.
Requirements for p-hat.
So it has to be NP is greater or equal to 10, and N times 1 minus P has to be greater or equal to 10. I think.
I'm gonna double. That is correct, but I'm gonna write that down. Yeah, so that's greater than or equal to.
Mm-hmm.
And N. P. Okay. Perfect. Requirements for P. Okay, that was correct.
Okay.
The value of our test.
So that last one we just did, what was the value?
1.768. We did.
That's what I got.
We go 1.768. The p-value of your test is 0.0 039, which is also correct.
Okay.
Is there sufficient evidence to conclude that graduates from the top 10 business programs perform better than other investment managers? Now, this is another one of those questions that's backwards. So the p-value is 0.039, which means it was less than the level of significance, right?
Right.
P-value is low, so the HO must go. So I reject.
Yep.
Oh.
Yes, I rejected the null.
So what the HO was saying that there was. Yeah. Okay.
Yeah.
That is the correct answer. Yes, I reject HO.
Yep.
So it's either
That one
you
right.
reject
You
the
reject the null or you fail to reject it.
don't do anything with the HA ever.
You never accept.
Okay.
You never accept anything.
I will remember that.
Yeah, I know. I'm just trying to like give you the best odds so I can always like cross off as many as possible. Okay. Okay. Information. Oh.
Did you look that one up? Was that one right, Cassie?
Yeah. Yes.
Yeah, you either reject the null or you fail to reject. Those are your only options.
Okay. The following information to answer the next 6 questions. A lot of information. Okay.
Now I gotta see what I put this.
Computer software is commonly used to translate text from one language to another. As part of his PhD thesis, Philip Cohen developed a phrase-based translation program called Pharo. The quality of the translation can vary. A good translation system should match a professional human translation. It is important to be able to quantify how good the translations produced by the Pharo are. The IMB T.J. Watson Research Center developed methods to measure the quality of a translation from one language to another. One of these is the bilingual evaluation understudy, the BLEU. A BLEU score is a number ranging from 0 to 1 that indicates how well a computer translation matches a professional human translation of the same text. Higher scores indicate a better match. BLEU helps companies to develop translation software to monitor the effect of daily changes to the system in order to weed out bad ideas from good ideas. To compare Pharo's ability to translate with similar computer translation software, Cohen took a random sample of 100 blocks of Spanish text, each of which contained 300 sentences, and used Pharo to translate each of these to English. The BLEU score was calculated for each of the 100 blocks. These scores are recorded in the data file. He wants to use this data to see his mean BLEU score differs from the mean BLEU score of another leading translation software, which has a population mean score of 0.295. Assuming the requirements are satisfied, conduct a 95% confidence interval for Pharo's true mean BLEU score. Record your answers below.
All we want is it differs from the mean. So we know it's a mean test, so it's not a proportion test.
So that
and it's really, if you look up the BLEU data, that helps you go to the data sheet. Because there's only one set of data. That tells you right there. It's a
one sample.
Yep.
Oh. Okay, command copy. So that means, let's see. Where does this go?
But it's a one sample t-test because you're looking for the mean, not the proportion.
What about the z's? So explain that again, Chase. Why it would be a t instead of a z? Do we have?
It depends whether or not you know what the sigma is.
Got you. Okay, so we need the one sample t-test.
T-test, because we do know what sigma is.
Wait, we do know what sigma is?
Yeah.
I think.
So one
Yeah.
sample z.
Isn't sigma the mean?
No, sigma is the standard deviation.
Sigma's a standard deviation.
So we don't have
No, we don't have the standard deviation, so it's a t-test. If we have the standard deviation, then it's a z-test.
Okay. So one sample t-test, and you just put it in the one variable.
Yep.
Okay.
Oh, okay. Yeah, the unknown is the t-test. Yeah, okay, so we're doing it right the whole time.
Mine didn't come up with the mean, standard deviation, or n. Heck. I'm gonna do this again. Okay.
But we won't need it. Nope, they're not going to ask you for it.
Oh,
It's asking for lower and upper bound.
okay.
Which is point.
Okay, so the
The lower bound, did you get 0.282?
Yeah, for the lower bound.
Yep.
yes. So the lower bound is 0.282, which is correct. And then input the upper bound, which was 0.293.
Mhm.
Yeah.
Calculate the degrees of freedom. Is that just 99?
Yep.
That is the correct answer.
99, you said?
99. Input the test statistic. That's a big one.
Right there.
3683. Did you guys get that?
I got
got
2.803.
That's what I got.
Mine says negative 3,000 or 3,683. Heck.
Okay, something's off.
I got the exact same thing.
Did you what's your null hypothesis?
No,
Did you change it to the 0.295 that they gave us?
Okay, that changes it to negative 2.803.
Yeah.
Thanks, guys.
Forgot about that part too, because mine was the same as yours.
Like, what the heck? 3,000?
Well, at least you know that's wrong.
Negative 2.803 is correct.
Okay.
Input the p-value.
All right. And
Is
we're
this a
looking
greater than test?
0.997.
Oh, this was not equal to.
Oh, it's also supposed to be not equal to?
So that changes to 0.006.
That's what I got.
Yep.
Okay.
Hold on. 006. And that is correct. And based on the results of,
We're getting there, you guys. We're getting there.
yes. Based on the results of this test, what would you conclude? So it's level of significance A equals 0.05, and the or the p-value is low, so the HO must go. So there is
It's
sufficient.
lower than, so we have sufficient.
There's sufficient evidence to say the true mean is different.
Yep.
So it's insufficient, right? Because it's bigger than 0.05.
Yep.
0.006.
Yep.
Is bigger than
Yeah.
0.05.
No, it's smaller.
Oh, it's 0.006. Yep. Family excited.
Okay. So we have, is that right? We have sufficient evidence to say the true mean
That's
Is
right.
different.
That is correct. We have sufficient evidence to say that the true mean is different than 0.295.
Okay.
Okay.
Go.
So now we can do, and we are into use the following information to answer the next 6 questions. The notion that people are taller when they first wake up in the morning than in the evening, right before they go to bed. To test this theory, the heights of children in boarding school in India were measured. Values were recorded in millimeters for each child in the morning and again in the evening. The data is recorded in this file. We want to determine if the children are taller in the morning than in the evening. Define the differences of AM height minus PM height. Construct a 95% confidence interval for the true mean differences of heights and conduct a hypothesis test to determine if the children are taller in the morning than in the evening. And put your implant below. And we have, would it be a 2-sample?
Wouldn't it be a paired sample t-test? We're looking for differences.
But don't they want to know, let me see, define the differences to the notion that people are taller. So it's a comparison. It's this,
Is it asking for independent or dependent samples? Like,
Well,
is that what it has?
They're using the same kids. They're using the same kids, but
paired?
I'm thinking it's just a 2-sample t-test.
Well, because it's minus 2.
I have to walk away for a minute. Sorry.
Does the 2-sample t-test minus them?
No, the paired sample, what it says.
Because it says, define the differences as AM height minus PM height.
Oh, so yeah.
So AM height minus PM height. So the AM height is the variable 1.
So it's a paired?
I think.
Yeah, it is. You're right. Yep, it is. It's paired, like Cammie said, because that's subtracts it. So are we taking the AM from the PM?
Okay, so yeah, so AM is variable 1, minus PM, which is variable 2. So input lower bound of your confidence interval. You're at 8.728.
I'm still putting mine in 1 sec. I put it in the wrong one.
Right, 8.728.
And that is the correct answer. We're doing good.
All right.
Okay, so
Okay.
a paired sample t-test where you do AM minus the PM.
What was the lower bound?
8.72.
8.72?
8.
Cassie, did you say
We decided-
8.72?
8.728.
Oh, okay.
8.728. Yeah, I got that too.
Input the upper bound, 10.455. Do you guys get that?
Yeah, I did.
Okay. That is the correct answer. Okay, so this is where it gets, what is the type of test? The differences are just not equal to, right?
What was that?
It's looking at the differences, so the type of test would be not equal to.
Yes, that's what I would think.
Okay. Did you guys get 22.446?
Hold on. Not equal to 22.446. Is that what you said?
Yep.
That's really high. Is that the answer?
That is the correct answer.
Okay.
Well, the p-value is even more ridiculous.
What about degrees of freedom?
Is 40. Right?
Yeah.
Mm-hmm.
Yep, 40 is the correct answer. The p-value for this test.
So how do you do this one with the E and everything?
With the E? Oh, I don't know.
It means that there's however many however many numbers after the E are how many zeros there are
Oh.
to the right of the decimal before the actual number starts. So it must be.
What?
So it'd be 0.000.
Yep.
Wait, how did you get 0.0?
If there's, go ahead, Cammie.
Because it's like 2.94 is the number with the E minus 24. That means there's 24 zeros in front of what you actually see.
Oh,
So that should be 24 spaces in front of the 2, or 23 spaces in front of the 2. So that means the first 3. And the first 3 are going to be 0, 0, 0.
that is the correct
So then,
0.00.
that's funny.
Still gotten that wrong. That's so good to know.
Yeah,
Yeah, I would have gotten it too.
anytime you see all the numbers and then it says let's say it says E10 or E23 or E whatever, it means that there's that many zeros decimal before the actual numbers start.
Based on, no, that's super, super, super helpful. Based on your report of this test, is there enough evidence to suggest that children are taller in the morning than in the evening? P-value.
Yes, because we rejected the null.
Wait, would it be no because we rejected the null? What was the null hypothesis? This is where I get confused because I know we reject the null because the p-value was low. Enough evidence to suggest that children are taller.
Okay, so it says a study was done to test the notion that people are taller in the morning. Go to bed. So the null was, it sounds like a study was already done saying that they are taller in the morning when they first wake up than right before they go to bed, but we rejected that.
So yes, because we
rejected the null, yep.
Okay. That is correct, yes, because we rejected the null. Hey, this is where we turn it in.
Well, we still have to do 28.
What?
To figure that one out, right?
What about 28?
Oh, Amber wants me to send, I didn't notice this, you guys. She wants me to send her a picture of 28. So hold on one second and then she can tell us how to do it. Okay. My phone's turned off. I didn't see that she wrote me back.
I'm going to turn it in to see if it is correct.
Okay. So for that last question, when it asked about if there's enough evidence, I always think of if you reject, then yes, fail, no. Remember it. So if it asks if there's enough evidence, and if I fail, then it's insufficient always.
Yeah. So if you fail to reject, it's insufficient, so you don't have enough evidence. But if you
Yeah.
reject it, you do have, you're genius. Genius. Like that. I knew that, but I just couldn't form it in my head. Good job.
Yeah, and if you ask me why, I wouldn't be able to tell you. And then that's just what they told us.
So yes equals sufficient, which means we failed it. No equals insufficient because we.
Okay, let me send this to her and she'll get back and tell us how to do that.
Okay, so evidence is going to reject. No. When you have sufficient evidence, you can reject it. Okay, I'm sending. Okay, we got 100%.
Cool.
You guys want to wait for her to get back to us, or I can just forward the text to you guys to show you how to do it?
We'll probably forward it.
Yeah, then you guys won't have to wait.
Yeah, I've got a mess to clean up.
Same.
Hey, yeah, she usually gets right back to me, so I'll just send it to you guys.
Okay, sounds good.
Thank you.
You don't have to meet, right? I'm gonna look at the. Yeah, so this is all we have for this week, right?
Yep,
Yeah,
this is it.
just the quiz and the exam. That's it, which is really nice.
The data. So, Tammy, I'm glad you're here. We decided last week that, let's see, Sherry and Chase were splitting Wisconsin, right?
Yeah.
Yes.
I was doing California, and Tammy is going to do. Is it
Let's see. I watched
New
the video.
Jersey. New Jersey.
Okay, so Cami, we need to, what I did was you like Google town lists or list of cities in New Jersey, and then you'll have a list pull up, and then you can go to random.org and it'll give you random numbers to count to pick the cities, or you can just randomly pick the cities yourself, whatever. Once you pick the city, just Google the mean median of home prices in that city. And Google will bring it up automatically.
Okay.
The mean,
So the mean home prices is what I'm looking for?
the mean median.
Mean median?
So I think it'll come up as a median home price.
Okay. Median price.
Yep.
Yeah, are we looking for a specific kind of house or just house in general?
Just the house. So median home prices of like regular items, you know, like it'll pop up with that price. And I will send you guys in an email. I will send you a collect the data page that we already have. That already has for you to input your own data into it. I'll just
Okay.
that makes sense. I will email that to you guys after. Okay. Yes.
Chase and I did like every 30th city. I just opened it up and picked every 30th one. So they're supposed to be random. So we just did every 30. So whatever you want to do.
Gotcha.
Yes, so we all have to turn in or collect the data this week. I don't think we have to, oh, it does say collect and describe the data instructions. Okay, so we do have to, Jerry, this is where you describe the data. I think there's a page for that, like an outline page. I'll double check.
That's for next week, right?
Yes, describe the data instructions. We might have to, let me see if it's next week.
It says you will submit your collect and describe the data assignment by due date number 2 of week 12.
Yes, so that is next week that we turn it in. So we can get started on it this week. If you guys are busy with Thanksgiving and stuff, don't stress about it because we have next week to really do it.
Okay, and then next week, if you guys can just send me what you find, then I'll put it all together.
Yep.
Okay.
So preferably have the collect the data, like you're part of the collect the data, probably by like Monday or Tuesday. That way Sherry has enough time to be able to describe it and turn that in. We don't have to turn it in. We only turn in to describe the data. We turn in our part of the collect the data. Everybody individually.
Okay.
Okay. Okay. Sounds good.
Good luck on your test, guys, and have a happy Thanksgiving.
Thanks so much. You guys have a happy Thanksgiving. All right, talk to you.